Alright, so in this video we're talking about linear combinations, and in particular the question has come up here whether or not this vector here on the left hand side, minus 2, minus 6, minus 6, minus 4, is a linear combination of these three vectors here on the right. So in order to answer this question, we take two steps. First, we're going to write an equivalent statement using vector equations, since vector equations are a type of thing we've dealt with before, and then we're going to use said vector equation to determine if this is true or not. So let's go ahead and start by rewriting this statement as a vector equation, and we want to ask ourselves is, what does it mean for a vector to be a linear combination of a bunch of alpha vectors? And if we recall, what that means is that I can find scalars for these three vectors. So I take their scale, I scale them, I sum them together. In other words, I combine them so that I get this vector on the left here. So the equivalent statement is the equation, and what this equation is going to look like is x1 3 2 minus 5 minus 3 plus x2 0 1 minus 3 1 plus x3 4 minus 3 minus 3 0, that is somehow equal to minus 2 minus 6 minus 6 minus 4. And our claim is that this equation has a solution. At least one solution would be good enough, right? Okay. So this doesn't tell us whether or not it's true, but it's what we need, what we needed in order to actually answer that question. So now that we've written the original statement as a statement about a vector equation, we can go ahead and solve it. And so now we're back to solving vector equations, which as we know is equivalent to solving system of equations, which we know can be broken down to be a statement about augmented matrices. So let's go ahead and write down the augmented matrix form of all of this. So we have 3 2 minus 5 minus 3, 0 1 minus 3 1, 4 minus 3 minus 3 0, and augment, and then our constants, minus 2 minus 6 minus 6 minus 4. And if we want to know whether or not this thing has valid solutions, we want the reduced row echelon form of this once again. And also once again, I have no desire at all to actually solve this thing by hand. So let's go ahead to Desmos here. If we recall, we had 4 rows and 4 columns. And so let's go ahead and punch in our columns. 3 2 minus 5 minus 3, 0 1 minus 3 1, 4 negative 3 negative 3 0, and finally minus 2 minus 6 minus 6 minus 4, giving us a reduced row echelon form of 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Alright. So that's our reduced row echelon form. And once again, sort of the row of significance here is this last row, right? We have once again the claim that 0 is equal to 1, which is clearly not true. So as we recall, what this tells us is that this system has no solution. So the above equation has no solution. And what that tells us is that the claim that it does have a solution is false. And that means the original claim is false. So, the original statement is false. And what we can conclude is that -2 -6 -6 -4 is not a linear combination of the three vectors on the right. Okay, thank you.